first billion years of existence, the formation of life on Earth was prevented by a combination of comet and asteroid impacts. Making the Earth's surface too hot for water and carbon molecules to exist. Life on Earth began at the end of this period, called the Late Heavy Bombardment, about 3.8 billion years ago. The oldest known fossils on Earth date back 3.5 billion years, with evidence suggesting biological activity occurred earlier at the end of the Late Heavy Bombardment. Therefore, the chance for life to begin was very low. As soon as life could form on our planet, it appeared. But if life formed so quickly on Earth and there was very little water and carbon molecules on the planet's surface, then how were these building blocks of life delivered to Earth's surface so rapidly? The answer may involve comet and asteroid collisions with Earth. As these objects contain abundant supplies of water and carbon-based molecules, once the initial comet and asteroid rains on Earth subsided, subsequent impacts could have delivered water and carbon molecules to Earth's surface, thereby providing the building blocks for life itself. It seems that the origin of life on Earth's surface was first prevented by a very large stream of impacts from comets and asteroids. Then a less intense comet shower may have deposited the very materials that allowed life to form, around 3.5 to 3.8 billion years ago. Later comet collisions may have wiped out many developing life forms, allowing only the most adaptable species to evolve first. However, upon deeper research, scientists have found that Earth's habitability to this day is essentially due to luck. It took 3 or 4 billion years of evolution to produce modern humans like us today. If the climate had completely failed just once during that time, then evolution would have stopped and we wouldn't be here now. So, to understand how we can exist on planet Earth, we need to know how Earth managed to sustain life for billions of years. This is not a trivial matter. Current global warming shows us that the climate can change significantly within the next few centuries. Over geological timescales, changing climate is even easier. Calculations show the possibility of Earth's climate deteriorating to temperatures below freezing or above boiling within just a few million years. We also know that the sun has become 30% brighter since life first developed. In theory, this should have caused the oceans to boil by now, since generally they were not frozen on early Earth. This is called the faint young sun paradox. However, somehow, this habitability puzzle was solved. Scientists have proposed two main hypotheses. First is that Earth may possess something like a thermostat, a feedback mechanism or mechanisms to prevent the climate from ever reaching lethal temperatures. Second is that, among many planets, perhaps some planets pass through by luck, and Earth is one of them. This second scenario becomes more plausible due to discoveries in recent decades. Of many planets outside our solar system, which we call exoplanets, astronomical observations of distant stars tell us that there are many planets orbiting them, and some have sizes, densities, and orbital distances that could theoretically have temperatures suitable for life. It is estimated that there are at least 2 billion such candidate planets just in our galaxy. Scientists have been observing these exoplanets to find out if any of them match Earth's billions of years of climate stability. But even the nearest exoplanets, like those orbiting the star Proxima Centauri, are more than 4 light-years away from us. Therefore, it is very difficult to obtain observational or experimental evidence. According to research by Toby Tyrrell, professor of Earth System Science at the University of Southampton, UK. He used a computer program designed to simulate climate evolution on planets in general, not just Earth. For the first time, Toby Tyrrell created 100,000 planets, each with a different set of random climate feedbacks, Climate feedbacks are processes that can amplify or reduce climate change, such as Arctic ice melting, replacing ice that reflects sunlight with ocean that absorbs sunlight, thus causing warming and more ice melting. To investigate the possibility that each of these diverse planets can be habitable over huge geological time spans, Toby Tyrrell simulated each planet 100 times. Each time, the planet started from a different initial temperature and was exposed to a series of random climate events. These events represent climate-altering factors, such as volcanic eruptions and asteroid impacts, like a collision that killed the dinosaurs. In each of the 100 runs, the planet's temperature was tracked until it became too hot, too cold, or it had survived for 3 billion years without problems. It was considered a potential candidate for intelligent life. The simulation results provide a clear answer to this habitability problem, at least regarding the importance of stable climate feedback and the element of luck. The results show it's very rare. Only 100 out of 100,000 planets have feedback so strongly stable that they remain habitable in all 100 runs, regardless of random climate events. In fact, most planets that were habitable at least once achieved this fewer than 10 times out of 100. In most cases in the simulation, the planet remained habitable for 3 billion years. It was partly due to luck. At the same time, luck alone was not enough. Planets specifically designed to have no feedback at all were never habitable, meaning the randomness of climate events never passed the test. This overall result, partly dependent on stable feedback and partly on luck, is very robust. Any changes to the model did not affect it. Therefore, Earth must possess some stable climate feedback. But at the same time, luck also played a role in allowing life to exist. For example, if an asteroid or solar flare had been slightly larger, or occurred at a slightly different time, we might not exist on Earth today. It offers a different perspective on why we can look back at history, of how life developed, diversified, and became increasingly complex on Earth. Subscribe to the D&Neo channel.